Well, Assalamu alaikum dear students, I'm Engineer Abdul Basit, and today we are going to start a new subject, that is hydraulics. Okay, particularly in this subject, this first lecture, as we are in week number 1 and lecture number 1, so we'll talk about some introduction of the fluid mechanics and hydraulics, some basic concepts, and also some basic terminologies regarding hydraulics and fluid mechanics, so that if we move further in the subject, we'll discuss these things in detail as well. And later on in the subject, we will cover some discussion about a determination of discharges, velocities, and different devices used for manometer, hydrometer, and piezometers, and different types of devices and tools that are used to determine different types of properties of of water, in both in static and in motion. Okay. Then we will discuss about open channel flow and that pipe flow as well, and different properties regarding that. Later on the subject, we may also discuss about the different types of hydraulic structures, like dam structures, weirs, and barrages. That is particularly, you can say, a topic that is related to civil engineering students. And then at the end, we will discuss about the different types of turbines. Okay, how they react to the flow of water, and how they work, how they generate water, that electricity, that power. Okay, and that power generation process will be illustrated to you using that penstocks and different types of elements or components of that dams and hydropower generation assembly. uh, First of all, in this lecture, introduction is our core concept, so let's do it. First of all, this is basically a 3 credit hour subject. Okay, so according to for my students, the timetable is like on Wednesday we are having class on 2 p.m. and the code of the subject is CE102. Okay, the goal of this subject is intend to provide understanding of statistics and dynamic concepts of fluid flow. Okay, so here we will try to cover some basic concepts and some details about statics and dynamics of the fluid flow. Okay, so simple is that we will discuss water or fluids in both static and dynamic form, both in rest and in motion. Okay, so the course descriptions is like, if I read this para for you, that is, the course provides students with basic information on statics, kinematics, and dynamics of fluids. Okay, so statics is actually like when water is at rest. For example, in dams, you are constructing a barrier in front of flow of water, and that water flow is stopped. The water came to rest, and then if you are studying the properties like the pressure on the main barrier of the dam, that settlement of sediments in the dam, that pressure on the side bunds of the dam, so that will be something related to fluid statics. Then coming to kinematics, so kinematics is actually a property that is like, for example, if a body is acted upon by a force, and some effect is produced, some motion is produced in the body, velocity or speed, acceleration is produced in the body. So if we are studying the effects of the forces and neglecting the forces that are creating these effects, then it is called kinematics. So in fluids, if we are studying the flow of fluid, the stream flow, the laminar flow, the turbulent flow, that flow in particular direction, that silting, settle, non-silting, non-covering velocity, and different types of other concepts like discharge, etc. So these also will be covered here in the kinematics. Then coming towards dynamics of the fluid, so dynamics of the fluid is the properties of fluid in motion, that maybe the force due to motion acted on the on different bodies coming in the way, so that may also be discussed. These includes the study of properties of fluid, statics, translation, rotation of fluid. So translation is like stream flow of the fluid, but rotation actually refers to vortex flow that will be discussed later on in this subject in few coming lectures. Dimensional analysis and similitude. So dimensional analysis and similitude is particularly that prototype concept of the heavy structures or heavy hydraulic structures. Okay, so that will be discussed later on, or you can say in the last quarter of this subject. And then fundamental of fluid flow, fluid resistance, compressible flow, ideal flow, and then fluid measurements. So all these concepts are related to these few earlier discussed topics. So these will also be covered at measurement and resistance etc. So fluid resistance is particularly that resistance to the flow, which is viscosity. Okay, that will also be discussed later on. The book that I'm recommending for this subject is the very simple book that is written by R.S. Khurmi in simple SI units, and all the basic concepts and some detailed concepts are also covered in this. So on BS level and MS level, this book and even at diploma level, this book is very useful to study. And the title of the book is Hydraulics, Fluid Mechanics and Hydraulic Machines, and the author is R.S. Khurmi, as I mentioned earlier. Here is a sketch of the book, or you can say the front page will look like this. That is R.S. Khurmi and N. Khurmi. These are the two authors of this book. Okay, so you can have that latest 14th edition of this book. Course topics. So course topics, as I mentioned earlier: introduction to fluid mechanics, this file. So it will be covered in this file in this first lecture. Then fluid properties. So in the coming lecture we will discuss about few basic terminologies or fluid properties. And then fluid statics. Okay, fluid statics is as I mentioned, study of fluid at rest. And fluid dynamics is like you can say vice versa. And fluid flow measurements, dimensional analysis and hydraulic similitudes, dynamics of viscous flow, fluid flow in closed pipes and on open channel pipes. So all these things will be discussed later on in this subject. So if you do know about this subject in detail, that what topics may be covered here, so I recommend you to skip this video or till this point. Okay, this fifth slide. And if you don't know about the basics of this subject and what are the basic content of this subject may be, so then you should watch this whole video in detail. Assignments, projects, and that will be 10% of the subject, the assessment criteria is. And there's quizzes, per chapter will be at least one quiz, and that is 10% of the total marks. This is assessment criteria. Midterm exam will be of 30 marks, and the final term exam will be of 50% marks of your total grading. Now coming to the very first sorts of discussion for you, like for example, if you are a civil engineer and you are studying the fluid, so what is the basic need for you to understand, and why you are studying this subject? Okay, so your concentration will be particularly on those structures which are related to civil engineering concepts, like dams, like barrages. Like for example, you can see here, this is overhead water tank. Here it is a pipe, you can say, for water supply or sanitation. So civil engineers are having these headaches to solve. So then if you are a civil engineer, so you should study the fluid mechanics for your own use. That will be these structures. Okay, weirs and barrages and dams are included. But if you are an electrical engineer and you are studying this hydraulics or fluid mechanics. So your basic aim should be to understand about the power generation concept, how the power is generated using that hydropower uh, that hydropower generation process, or you can say that energy of potential energy of water. So then you should know this concept. So simple, the potential energy of water that is on the upstream side, when it is falling on the turbines, it's rotating turbine, so then that Fleming rules come in power, and that will create like a magnetic field and current, and that rotation or motion. So if any of these three things is controlled artificially, then the third one will be automatically created. For example, if you want to produce some electric power, so you should give some motion to the turbine. Okay, so you can say the turbine will move in the magnetic field and the current will be produced, and that will be then utilized as hydropower. Okay. So this is a flow chart for that process. Okay, we will discuss that later on in the second half of this subject. Then coming towards some more concepts about fluids regarding electrical engineering. So electrical engineers use the application of hydraulics in electrical engineer is about turbines as well. Or you can say mechanical engineers may also take this application as in their own account. That is, when water is coming from one side through the penstock, and these blades are encountering that water. Okay, so you may say that these blades will be in contact with the flowing water, and that potential energy of the water, or you can say the flowing energy, will be converted to that mechanical energy, that rotation of the turbine, and that on other hand will rotate the turbine, or you can say that in that magnetic field. Okay, and current will be produced. So this is how it will work, that will be discussed later on. Okay, in this subject. Now coming towards some basic concepts. Fluid mechanics is for example, first of all, you should know about fluids. Before coming to the basic concepts of fluid mechanics, you should know about fluids. Okay, what is fluid? Fluids are substances which are capable of flowing and conforming the shape of container. Fluid can be in gas or liquid state. Okay, so you can say fluids are those substances which are number first thing is that is fluids are those substances which are capable of flowing. Okay, so solids cannot flow. Okay, plasma cannot flow, but fluids can flow. Okay, and in fluids you can say that both gases and liquids are included. So both gases and liquids are flowable, they can flow. Okay, the second property of the fluid is that it will adopt the shape of the container in which it is placed. Okay, so whether it is gas, whether it is liquid, it will adopt the shape of that container in which it is placed. Okay, but particularly for gas, it should be a closed container from all the side to give that shape to gas. Okay, otherwise that gas may flow away from that container. Okay, but in case of liquid, so as liquid is something heavy, that will settle down in the container and will adopt the shape of the container. Okay, but the broad concept for both is the same, that it will adopt the shape of the container in which it is placed. Okay, so you can say fluids are basically having these two properties, flowability and adopting the shape of the container. Okay, then talking about mechanics, as this fluid mechanics word is consisting of two topics, fluids and mechanics. So mechanics actually refers to, mechanics is the branch of science that deals with the state of rest or motion of a body under the action of force. Okay, so if a body is under in rest or in motion, okay, due to any force acting upon it, okay, whether that force is creating motion in the object or it is bringing that object to rest. Okay, So the study of this phenomena is actually mechanics. So earlier in this lecture I've discussed about kinematics. Kinematics is actually something opposite to this, or reciprocal to mechanics. In kinematics, basically we are having two things. For example, uh, we are kicking a ball, okay, and the ball is coming in motion and is having some projectile motion, okay. uh, that motion of the ball, that velocity, that speed, that acceleration, that projectile motion of the ball, when it is discussed, when it is studied, that is called kinematics. But ignoring the force that is applied by the kick, okay, by our legs, so that is ignored. But in mechanics, the situation will be against this, or opposite to this. That will be that motion of the body of the ball, that velocity, that speed, acceleration is ignored, that is not discussed. The main discussion will be on the force that is being acted by that leg or your kick, okay. So same is the concept with all bodies. If that force is produced by fluids, if that force is produced in the fluids, okay, then their discussion is actually the mechanics. So if it is about fluids, then it is fluid mechanics. Coming to fluid mechanics, branches of mechanics that deals with the response or behavior of fluids either at rest or in motion. So that is the same thing, combining these two. Mechanics of fluids is actually the fluid mechanics. Then coming to the branches of fluid mechanics, so that is fluid statics, fluid kinematics, hydrodynamics and hydraulics. So fluid statics is actually that branch of fluid mechanics in which we study the fluids at rest, the behavior of fluid at rest, the properties of fluid at rest, the forces on the fluid are by the fluid at rest. This is called fluid statics. So particularly that water that is of which the flow is being stopped by the barrier of the dam, and the water that is stored in the reservoir, that study of that static water is actually that fluid statics. Fluid kinematics, it deals with the response of fluid when they are in motion without considering the energies and forces in them. So I have elaborated this concept two times in this lecture earlier, okay. uh, Hydrodynamics, it deals with the behavior of fluid when they are in motion considering energies and forces in them, okay. Hydrodynamics is actually um, a combination of both, okay. You can say kinematics and mechanics. So here the forces and the effects of the forces both are discussed and studied, okay. So then it is called hydrodynamics. So if it is about water, then it is hydrodynamics. Hydraulics, it is the most important and practical experimental branch of fluid mechanics, which deal with the behavior of water either at rest or in motion, whatever the situation is. But you can say specifically the study of water in any situation, that is called hydraulics, okay. So coming to the dimensions and units, so these are some basic units that is that will be used further in this book or in this subject. First of all, SI units, that is meter, kilogram and seconds. British gravitational system, that is consisting of these three basic units: foot, sludge and second. This is British gravitational system. And CGS system is actually centimeter, gram and seconds. So these are actually those physical quantities which are having these units. So English units and SI units combination is present. Length can be measured in inches in English unit, while 1 inch is equal to 2.54 centimeters, okay. And centimeter is the unit of length in SI, or you can say in meters. It will be also it can also be counted. And feet can also be the unit of length in English units, and meter can be in SI units. And these are the conversions given as well, okay, for mass, for force, temperature, pressure, power, magnetic field. So all these things are given. You can see this in your own way in detail. Okay, and that's all about this lecture, introduction lecture. Inshallah, in next lecture we'll try to cover these few concepts, that is density, specific weight, specific volume, specific gravity, and viscosity, and Newton's law of viscosity. So till then, thank you very much for watching the video. Assalamu alaikum.